Okay, this one. Factoring is going to be a little bit more difficult because we have a negative in front of the 2x squared. So I'm going to give you two ways of factoring this, two different options. Option number one is deal with that negative. How do I get negative 2x squared? I would have to have a negative 2x and an x. That's my only possibility. How do I get my last term to be a negative 2? I'm going to need a 2 and a 1, and I need my outside and my inside to make 5. So if I put my 2 here, my outside is 4, 1 there, my inside is 1, that could make 5. Let's see if we can make our positive and negative values make that work. So I need a positive 5. So if I make this negative 2, my outside becomes positive 4, and this 1, that would make positive 5. I need to do a quick check. Is my last value still going to be negative 2? It is. So this is factored correctly. Okay? Sometimes factoring with that negative is difficult. So sometimes people factor out that negative to begin with. Can you see that if you do that, you would get inside 2x squared minus 5x plus 2. And just because you've done it so many more times, so I still have this negative factored out in front, it might be easier to factor this because you know it has to be 2x and x. To get 2 is going to be 2 and 1. This one would have to be plus. This one would have to be, no, they would both have to be negative, I'm sorry. Right, to get a minus 5, they would both have to be negative. Notice that if you were to distribute this negative into this one, you get exactly the same as the first factor that's there. Either way that you'd like to factor it, it's fine. Now we can go to step 1. What's our non-permissible value? X can't equal 1. And that value is going to be a vertical asymptote at x equals 1. Do I have an oblique asymptote or a horizontal asymptote for step 2? Well, I have a higher degree on the top, so I'm going to have an oblique asymptote. How do we find our equation of our oblique asymptote? We use synthetic division, so we're going to need to divide negative 2x squared plus 5x minus 2 by x minus 1. So we put a positive 1 outside, bring down the negative 2, multiply and add, multiply and add. And so our equation of our oblique asymptote is negative 2x plus 3. Again, you don't need to worry about the remainder. So negative 2x plus 3 has a y-intercept of 3, a slope of negative 2. So I go down 2 over 1, down 2 over 1. And we can label our oblique asymptote as well. Find our y-intercept, plug in 0 for x, and we get 0, 2. Find any x-intercepts. Well, we've already factored it, and you can use either factored form. We will have an x-intercept at 2, 0 and an x-intercept at 1/2, comma 0. So again, I put in 0 for y, and I look at my factored form, and the only time a fraction is equal to 0 is if your numerator is equal to 0. So if this one's equal to 0, then x is 2. If this one's equal to 0, then x would be 1/2. Can you see that you would still get 2 if you use this factored form, and you would still get 1/2 if you use this factored form? That's important to notice, just in case you're wondering, well, what happens if I do this one? Will I still get the right x-intercepts? The answer is yes. And so if I plug those in, two comma 0 and 1/2, comma 0. Now in step 3, we often do extra points if we need them. We do not need any extra points because we, again, your vertical asymptote separates your graph into 2 sections. And we have points to the left of our vertical asymptote and to the right of our vertical asymptote. We can now graph our function towards the asymptote. So on the right-hand side, it would go like this. Okay? On the left-hand side, it would go like this. And I'm going to make an E10 error. So I would lose a half mark on my graph. What did I do bad? This error that I just did, I would lose a half mark on my exam for E10. Yeah, that's an E10 error is an asymptote error. My graph at the top here is not getting closer to my asymptote, it's getting farther away from my asymptote. So if I want to fix that, my graph needs to approach my asymptote and not get farther away from it. Question number 5.